All right, everyone. We're going to go ahead and get our new packet, our 4B packet. So go ahead and pick that up with the front table. We're going to do a quick little preview today, referring to slope. And we're going to, as a lot of us have been, we've been referencing slope a couple different times. We've been using it lightly, but we're going to go ahead and use it a little bit more specifically, especially when using something called slope-intercept form, which we'll be doing, during this part of the chapter. So we should know that slope is considered rise over run. Okay, when we're visually looking at it, we're essentially trying to figure out a number to give the steepness of a line, right? When we think of a mountain, right, you have ones that could be more steep, you have ones that could be less steep, okay, both in a positive and negative direction. So we'll be talking about that a little bit as we go, but just remember that slope is essentially a numerical value given to talk about or reference the steepness of a line. Okay, we're basically saying, oh, hey, how much does something rise in comparison to how much it runs? Okay. So anyway, we're going to go ahead and be doing that. So when you're looking at it vertically, we're going to use rise over run. You're going to see we have a couple different ways to reference it, whether we're using a formula. So we'll come back to that. But let's go ahead and start by finding the slopes of these lines. Okay. I'm going to go ahead and talk to you about the first one. Then I'm going to have you pause the video, see if you can find the slopes for the other one. So here we go. We are going to go ahead and I'm going to do my rise in red. So pick a point to start at, right? It does not matter which one you start at. Either way it'll work. So we're going to go ahead and start here, and note that I'm going to go ahead and you have to do rise first. And notice that rise sounds like it's always going up, but it's not. It could be up or down. So when I go up, it's going to be positive. So I'm going to rise 1, 2, 3, 4. I'm going until I'm even with another point that's specifically on a spot. Note that I can't go to this spot because it's not specifically on a whole number for x and y, or an integer value. All right, so here I rose 1, 2, 3, 4 in the positive direction. So my rise is going to be a positive 4. And then we're going to go ahead and we're going to run 1, 2, 3. I'm going 3 to the left, so that left is negative. So we're going to negative 3. And here we have a negative 4/3 first slope. Right? We usually put that negative in the numerator or out to the side. Either way is fine though. If you had it listed as this right now, that's totally fine. All right, so I'm going to have you pause the video. Then we're going to go ahead and find the slope for all the other ones. So give it a try. All right, let's go ahead and get the slope for all of these other ones now. So this one, actually just real quick to show you that we could have done this one starting from the other spot. We could have done rise of negative 1, 2, 3, 4. Again, negative because we're going down. And then it would have been 1, 2, 3 positive because we're going right. And note that that would have also been negative 4/3, which is the same thing here, right? So that negative sign basically just ended up in a different spot. And again, it comes out to the same value. All right, let's go ahead and do this one. I'm actually going to, you could go from point to point. I'm going to skip a point just to kind of show you the idea. Basically, we're going to have to simplify here. So I'm going to go up 1, 2, 3, 4, okay, to get even with this one. So I had a rise of 4. And then we're going to go ahead and run 1, 2. Okay, and what you should notice from here is that this value should be simplified. Okay, some of you will write it as 2/1 because it goes to be divided by 2, but this is not simplified either. Okay, so we're going to go ahead and change this to just 2. So when we're writing a slope, we're not going to put a 1 in the denominator. Sometimes you'll see people do that when we want to graph a slope like this, and that is fine for you to do temporarily, but if I ask for the slope is 2. Okay, I didn't mention this earlier, but the letter to represent slope is m. I think we've been talking about it a little bit. So really when we write our answer, we'll write m equals 2. All right. All right, I'm just going to do E real quick because it's the most similar to what we've been doing. We're going to go up 1, 2, and then we're going to run 1, 2, 3. So that's just going to be 2/3. I think I had this one in here to show simplifying. I don't know, I'm not sure. But basically, it's just 2/3. That's pretty simple. All right, let's talk about these other two. You might remember these are our special cases because they're completely horizontal, completely vertical. So if I were looking at this in terms of just rise and run, here to get from this point to this one, I don't rise at all. So my rise is 0. My run, is really whatever we want it to be. But in this case, we'll just go over 2 to get to this point exactly. So here we go, 0/2. This is not simplified. We're going to change this, but let's go ahead and do this other one first. So in this case, we're going to rise 1, 2 to get from point to point. So that's a rise of 2. And then we don't run at all. We're already at that point. So there's no running, so 0. So So let's look at these two special cases. We have one with a 0 in the numerator, one with a 0 in the denominator, and the question is, all right, well, which one of these is a 0 slope and which one is undefined? The way I like to remember it is that when the 0 is underneath, it is undefined, right? So this is an undefined slope, and this one is a 0 slope. Okay, so we have to make sure we actually write that. You cannot leave it as 0 over 2 or 2 over 0. This is not, it would not be your final answer. You also might remember the words hoy and bucks. Horizontal here means that this is a hoy, and notice the 0 that it has right there, right? The O. That refers to the slope, the middle letter on both of them. Bucks, it's a vertical line. It has an undefined slope, and there it is. I'm going to have you watch the Slope Dude video in a little bit. It's funny, cute, little monotonous video talking about how to identify whether a line is positive or negative just by looking at it. And that is a good one to help you, to identify these as well. So again, this is rise over run. It is used when we are visibly looking at a graphed line and we're trying to tell what the slope is. But we also will sometimes use a formula, okay? So just like rise over run, rise, we're essentially trying to identify what the change in y is, because y is up and down, whereas change in x is referring to left and right, and we're trying to figure out what how the x is changing, how much we move from left to right. And that's essentially what this is doing as well, right? y2 minus y1, well, that's the change in y, and x2 minus x1, that's the change in x. So we're going to go ahead and try one of those here in just a second. So we're going to find the slope between these 2 points. Now, if a graph was given, we could just use rise over run and count it, but we're going to pretend that this graph isn't here. So maybe I was just given these 2 points. So we're going to go ahead and do that. So I'm going to go ahead and label these right now. So I'm going to call this x1 and y1. Let's not get too confused with those numbers. All these numbers mean is that this is essentially my first xy point. This is my first point. This is my second point, xy, right? All points consist of an x and a y. So, we're going to go ahead and put those in there. So to start this out, I'm always going to write m equals, and I'm going to write these parts right here. So I'm going to do m equals, I'm going to write my division sign and my minus signs. This is going to really help us when it comes to some negative problems or problems that involve negatives in the future. I have students mess this up all the time. So let's always start with this, right? The fraction bar and the two subtraction symbols. Almost looks like a big division symbol. Again, it's going to save us so much. So here we go. We're going to do y2 minus y1. y2 is 2 minus y1, which is 1. And then x2 minus x1. So that's 3 minus 1. And this is going to get us an answer of m equals 1 over 2. And if we looked and counted the slope up 1 over 2, that would have been a rise over run of 1 over 2 as well. Take note, it does not really matter. We could have had these as our 2 points and these as our 1 points, and it would have worked out just the same, right? Let's just try it mentally real quick. So we can do y2 minus y1, that would have been 1 minus 2, which would be negative 1. And then we could do 1 minus 3, which would have been negative 2. And you could realize, oh, wait a second, negative over negative is a positive. This is 1 over 2, which is the same thing as what we had over here. Okay, so it does not matter which is which. It's the same way that when we're counting here, you could start from the bottom point and count up and to the left, or you can start from this point and count down and to the right. Notice that negative sign, we get one negative either way. This one was positive and this one was negative. Okay, so regardless, it comes out the same way that these points can be switched. Who cares which one you call 1 and which one you call 2? All right, we're gonna go ahead and do one more right here. This is on, I think, the next page. So we're gonna look at number 1 on that page, and here you can see that there's some negatives. So again, I'm gonna show you the benefit of writing this first. All right, so if you need to label these as y1, y2, or x1, x1, x2, no, I can't say it, wow, x1, y1, x2, y2. If you have to label it, you go ahead. I'm gonna go ahead and see, okay, negative 3 minus 5. And then I have, now just take note, I went in this direction, right? I cannot now do negative 2 minus 3, right? We can't change directions. We started from this point. This is my y2. This now has to be my x2, okay? So 3 minus a negative 2. You can either write minus a negative 2 like this, or you can have that negative sign just go down like that, right? That would be the same thing. So just make sure, that's why I keep this red sign or symbol here, or my initial symbol, because it really helps me to make sure I do the right thing with the negative. I don't forget it. All right, so let's go ahead and simplify this. It would be negative 8 over 5, and that just actually is simplified. We're going to leave it as an improper fraction when we write slope, because we like to see this as a rise over a run, okay? All right, so I have the answers down here below. Go ahead and pause the video, and then you can unpause once you finish the next 5 here. Okay, here we go. Here are the answers. All right, so here they are. Remember that if you have it over 1, you should simplify this. Even if you got this as -1, so maybe you got 4 over -1, same thing. You should bring that negative sign up and drop the 1. 1/5 is pretty straightforward, -3/7. Here for these two, 5 and 6, they were our special cases, so you should have got -4 over 0, or maybe you got 4 over 0, depending on which point you had first. Same thing here, you could have this as 0 as over +3, so whichever point you chose to be your 1 or your 2. And just remember that this should be undefined and should be 0. All right, let's look at our last one, last concept. So potentially, okay, normally, ready, we're given 2 points and we said, hey, find the slope. Well, potentially, you're going to know the slope, like right here, and it's going to say, go ahead and identify what the missing coordinate value is right here. Okay, so we have the x value right now in our second coordinate that we're missing. So what we're going to do is we're going to use the slope formula. So m, actually I'm going to make this thinner. M is equal to, I'm going to put the formula down, y2 minus y1 over x2 minus x1. And I'm going to plug in my values. All right, let me label them this time. x1, y1, x2, y2. All right, let's go ahead and do our formula starter like that, and then let's plug in our values. So in this case, 2 minus 3. And then we went 2 minus 3, so I have to do r minus 6. R minus 6. And actually, here's an important part that we missed. Normally, the slope is missing because that's what we're looking for. In this case, they give it to us, so we're going to put it right here. What you should notice we have here is a proportion. Okay, it's a proportion that we're going to solve. So I see right here 2 minus 3. I can simplify that. So I'm going to go ahead and do that. So I'm just going to bring down my 1 over 2 again. 2 minus 3 is -1. And then r minus 6. You might be thinking, oh, hey, this is a 1, this is a -1, or like you might be thinking in your head what this should be. But I'm going to go ahead and solve this with cross products. Okay, that's what I'm going to recommend. So -1 times 2. And some of you will try to think about doing this mentally. I want you to be able to show me algebraically that you can do it. So let's cross multiply. -2, I'm going to distribute 1 to both of these. That's really just going to keep it the same. And then we're just going to have to add 6. And that will tell you what r should be. And that would be r equals 4. Okay, so the value would have to be 4 here in order for this to have a slope of 1/2. So go ahead, I'll leave the work visible up here. Go ahead and pause the video, try this next one, and I'm going to just reveal the work. And here we go. All right, so here's the work. My Smart Notebook, being the basic version, is making it so you can't see that as well. Let me actually do this. That is a little bit better. Let me just drag it out. But anyway, the answer here is -9. I'll just bring it down. But yeah, same process. And there you go. So hopefully this helped you get started and allows you to get a start on the homework. So yeah, there you go. Have a nice day.